hence I've come now with a new module here at the end of this chapter. The chapter was actually over, but a new module I have come with called as Bond Convexity. I'll just write down here Bond Convexity. Alright. Children, this module additionally I am placing in your viewing library because the new study material has this particular concept of bond convexity, and in the latest exam they asked a question also on the same which was never earlier asked. So children, for that purpose I have come here with a detailed explanation of what bond convexity is all about. In this particular video, children, I'll be only taking up a few concepts connected to your mathematics of childhood. Okay, it was called as differential calculus or differentiation, or some of you must be calling it as derivatives. If you remember dy by dx, this is not the derivatives of futures and options that we study in SFM, financial management. No, this is the derivatives of the mathematics part you must have studied in your childhood. Some of you must have kept it as option also. So children, what I'm going to do is I'm going to just take up few basic points of this particular concept of differential calculus or differentiation or derivatives as you say it, and then once that is done in this video, then in the coming videos we'll slowly build a bridge from this mathematics to the SFM, and we'll end with what convexity is all about. Everybody, can we start? So children, as far as derivatives is concerned, differentiation is concerned, it is denoted as dy by dx. Okay, it is denoted by dy by dx. Let me at the outset only tell you, dy by dx indicates, okay, I'll write down here, it indicates the value, okay, it indicates the value of change, okay, it indicates the value of change in y for every 1 unit change in x. Okay, read this again. Dy by dx indicates the value of change in the variable y for every 1 unit change in x. Now children, do you all understand that for y to change due to a change in x, there has to be a relationship between x and y, there has to be a linear equation between x and y. X and y should be part of one equation. Only then when x changes, y will therefore react and change. So what dy by dx indicates? It indicates nothing but what is the value of change in the dependent variable y for a change in the independent variable x, and for every 1 unit change in the independent variable x. Now I'll just give you a simple rule on how to apply the dy by dx. Children, very simple, please pay attention. If I say that y is equal to x raised to n, okay, y is equal to x raised to n, then children, if I want to find out the dy by dx, see children, first of all understand y equal to x raised to n is an equation. That means when x changes, y will accordingly change. Now I want to know for every 1 unit change in x, y will change by how much, correct? For every 1 unit change in x, y will change by how much. So for that, the rules of derivatives are many. I'll just give you one simple small rule. I'm not a mathematics teacher here to go into depths of derivatives here, but whatever is necessary I will show it to you. So children, if I want to find dy by dx, which is I want to find the value of change in y for every 1 unit change in x, then the calculation is something like this. It is n into x raised to n minus 1. Okay, it is n into x raised to n minus 1, which means this n comes down into x raised to, and in the power you should do minus 1. Everybody clear till here? So let us try to take some numbers and understand this properly. Okay, so children, let's say, okay, I'll write down here example 1. Okay, I'll write down here example 1. I say that y is equal to 2x plus 5. So this is an equation between x and y, that y is equal to 2x plus 5. So if x changes, y will obviously change, but I want to know for every 1 unit of change in x, y will change by how much. For that we will now take the derivative, children. So dy by dx if I do on the LHS. On the RHS, you know what to do. Children, I told you that if it is x raised to n, okay, y is equal to x raised to n, then dy by dx will be n into x raised to n minus 1, correct? So now if you see 2x, in that you keep the 2 aside, okay? Now as far as x is concerned, children, do you realize it is x raised to 1, correct? X is nothing but x raised to 1. So that 1 will come down, so I'll write down into 1 into x raised to n minus 1 means 1 minus 1. Everybody clear till here? This is what you do for the derivatives. And children, as far as 5 is concerned, it is a pure number. There is no x attached to it. The derivatives of a pure number is always 0. Always remember this. The derivative of a pure number is always 0. Mathematics. Okay, now going ahead, because it's a constant, children, I hope you understand. 5 is a constant. Constant means whatever x will change, do you realize y will change accordingly, but this 5 will not get impacted, right? 5 is a constant. So children, because of that, there is going to be no movement in that 5, and therefore the derivative of a constant is always 0. Okay, there is going to be no change. So children, therefore, let me now go ahead. One more thing I will tell you. All those of you who have done portfolio management, I'm pretty sure you understand what I mean by the word constant. All those whose portfolio management is not done, children, I will be teaching in depth about what this linear equation stands for, what are equations, what is dependent variable, independent variable, slope, constants, everything I'll be teaching you when we do portfolio management. So right now, just basic mathematics I am sharing with you. Okay, now, so children, what did you understand? That you understood this particular rule for derivatives, and you also understood that a derivative of a constant figure, a constant pure number, is always 0. Everybody clear till here? Okay. So children, therefore can I say dy by dx is equal to, okay, dy by dx is equal to, so 2 into 1, children, is 2. X raised to 1 minus 1. 1 minus 1 means 0. So x raised to 0 is how much, children? X raised to 0 is 1. So children, 2 into 1 is 2 plus 0 is 2. So children, with that we get the derivative of this particular function here, that y is equal to 2x plus 5. We got the derivative of this function as dy by dx equal to 2. What does 2 mean? 2 means that y will change by 2 for every, okay, for every 1 unit change in x. Everybody clear? Y will change by 2 for every 1 unit change in x. Everyone following? Now let us see the proof of it, which means if x changes by 1, y should change by 2. Everybody clear with this? Now let's see how that happens. Let's take few numbers now. Okay, let's take few numbers. I'll write down the equation again. Y is equal to 2x plus 5 here upstairs. Y is equal to 2x plus 5. Okay, y is equal to 2x plus 5. Now if x is equal to 10, okay, if x is equal to 10, can I say y is equal to 2 into 10, that is 20. 20 plus 5 is 25. Can I say y is equal to 25? Next, if x is equal to, now I'm changing x by 1 unit, so I'll take x from 10 to 11. So if x is equal to 11, can I say y is equal to 2x plus 5? Children, 2 into 11 plus 5. 22 plus 5, that will become 27. Everybody clear? Next, if x is equal to 12, children, y will be equal to 2 into 12, 24 plus 5, that is 29. I'll take one last. If x is equal to 13, can I say y is equal to 2 into 13, 26 plus 5, that is 31. Children, can you see, do you have the eyes to see that as x is changing by 1, correct, as x is changing by 1 unit from 10 to 11, can I say y moves from 25 to 27, that it moves by 2. Everybody clear? It moves by 2. There is a change of 2 in the value of y for every 1 unit change in x. You can see again, as x moves from 11 to 12, okay, as x moves from 11 to 12, 1 unit change in x. Can I say y moves from 27 to 29? It is moving by 2. As x moves from 12 to 13, y moves from 29 to 31. there is a change of 2, and that 2 is what was taught to us by the derivative function. Everybody clear with us? So dy by dx is equal to 2 indicates that y will change by 2 for every 1 unit change in x. So now what I am going to do here is I'll just draw one small graph here. Okay, please be attentive. Okay, see, this is the y-axis and this is the x-axis. Okay, now children, x is 10, 11, 12 and 13, and children obviously y is 25, 27, 29 and 31. Because they are all forming part of a linear equation, y is equal to 2x plus 5, if I plot it on a graph, okay, which means if I just put all values of x on this axis and all values of y on this axis, the line will be a straight line. Okay, the line will be a straight line. And children, this line is straight because all points on this line are following this equation of y is equal to 2x plus 5. Okay, y is equal to 2x plus 5. Everybody clear till here? In fact, if I can just make you remember your mathematics a bit, if this line comes here, this point, children, okay, this point, I'll just redraw this. If this line is just stretched further and it hits the y-axis, okay, yeah, this point, children, is 5, because when x is 0, can I say when x is 0, y should be 5? Everybody clear? When x is 0, y should be 5, and this is that straight line. Everybody clear till here? So this is what was the first part of my explanation for the derivatives using this small example of y equal to 2x plus 5. Yes. Now children, I will take you to the second example. Okay, please pay attention. Now this is going to be slightly tricky. Okay, now my second example, write down here example 2. Okay, example 2. Let's say that the relationship between x and y is not a linear equation, it's a quadratic equation. Okay, so if it's a quadratic equation, how does it appear? Please pay attention. Y is equal to, just giving a random number, okay, y is equal to, let's say, x square plus 3x plus 1. Okay, x square plus 3x plus 1. This is a quadratic equation, and of course x and y have a relationship, so if x changes, y obviously will change. So I want to know, okay, I want to know for every 1 unit change in x, y will change by how much? Okay, for every 1 unit change in x, y will change by how much? Can we start? Please pay attention. Okay, now, so for that I will do dy by dx. Okay, dy by dx. Now children, on the RHS you see x raised to 2. Okay, you see x raised to 2. Children, tell me, how should I take a derivative on this function? You all know this 2 will come down, so this will be 2 into x raised to, and then this will be 2 minus 1. Everybody clear? 2 into x raised to 2 minus 1 plus 3 into, children, this is x raised to 1, right? So that will be 1 into x raised to 1 minus 1, and plus the derivative of this constant 1 will be 0. So children, can I say dy by dx should be equal to 2 into x raised to 1, that means, can I say it is 2x plus 3 into 1 into x raised to 0 is 1. So 3 into 1 will be 3 and plus 0. So therefore children, you now get your derivative function as dy by dx is equal to 2x plus 3, which means for every 1 unit change in x, y will change by 2x plus 3. Everyone clear with this? Can we go ahead? Great. So children, now see what I'm doing. If x is equal to 10, okay, if x is equal to 10, students, can I say y is equal to, now children, this is not the equation, okay, the equation is here. I hope you are able to see. This is the equation, okay. So children, if x is equal to 10, y is equal to 10 square plus 3 into 10 plus 1. Do you agree with me? 10 square plus 3 into 10 plus 1, which is equal to 100 plus 30 plus 1, which is equal to 131. Everyone agreeing with me till here? Great. So now children, we have understood that when x is 10, y is 131, correct? Let us also now calculate the derivative function for it. Okay, so children, we know that dy by dx is equal to 2 into x plus 3. So children, when x is 10, can I say dy by dx will be 2 into 10 plus 3, which is equal to 23. Do you all agree with me till here? What does this indicate, children? This indicates that y will change by 23 for every 1 unit change in x. Do you agree with me? Y will change by 23 for every 1 unit change in x. Now, children, let us change x and see. So, children, if x is equal to 11, okay, if x is equal to 11, 1 unit extra, do you realize that y will be 131, which was the value of y when x was 10, plus 23. Do you agree with me? Plus 23. Just as, children, if you remember here, when x was 10, y was 25, and the derivative, children, was 2, which means when x goes from 10 to 11, do you understand that y will be 25 plus 2? Everybody clear? 25 plus 2. Similarly here, children, when x is 10, y is 131. So when x goes from 10 to 11, 1 unit change, y should change by the derivative function, that is 23, which is 131 plus 23. Okay, 131 plus 23, this comes to 154. Everybody clear till here? 154. Children, let me now give you one more example, please. Let me give you one more example. Okay, if x is equal to 12, okay, if x is equal to 12, y should be equal to, now children, let's see how many of you are smart. If x is equal to 12, y should be equal to, see, y was 131 when x was 10, correct? I'll write down here, when x is 10, y is 131. So children, now if x goes to 12, that means x is changing by 1 or 2? 2, correct? From 10 to 12, there is a 2 unit change in x. Can I say y, which reacts by 23 for every 1 unit change in x? Can I say will react by 23 into 2, correct? So it will be 131 plus 23 into 2, correct? 131 plus 23 into 2, just give me a minute, okay? 23 into 2, which is equal to, on the calci, 23 into 2 plus 131, this should go to 177. Okay, this should go to 177. We will take 2 more examples, children. Okay, I'll just extend this line here. Okay, all right. So I'll just made the bifurcations here. Okay, now if x is equal to 13, can I say y should be equal to 131 plus, children, this will be 23 into 3. Everybody clear? Because x is changing by 3 from 10. So 23 into 3, okay, plus 131, this comes to 200, correct? This comes to 200. And children, if x is equal to 14, can I say y will be equal to 131 plus 23 into 4, okay, 23 into 4. So children, 23 into 4 if you do plus 131, this will come to 223. Okay, this will come to 223. So children, now if you see, of course the difference between all is 23 only, right? When x was 10, y is 131, plus 23 154, plus 23 177, plus 23 200, and plus 23 223. Everyone follow until here. Now children, let us just plot the coordinates. I'll just first of all write down the coordinates, children, x and y. Okay, I have taken few levels of x, 10, 11, 12, 13 and 14, and y we got as 131, 154, 177, 200 and 223, correct? 131, 154, 177, 200 and 223. Children, if these numbers I plot on a graph, okay, if these numbers I plot on a graph, I'll just make the x and y axis here. Give me a minute. Okay, yeah. So this, children, here is y, and if this is x, children, they are following a proper equation, and therefore they will all form a straight line. All the coordinates, children, you can try it later on a graph paper if you want, but will not waste time here. They will obviously be forming a straight line. Everyone clear with this? Great. Now, children, the concept starts. Please, please, please be attentive. Okay. Now, see, children, how did I find the value of y at different levels of x? By just taking this 23, that is the derivative function, and applying it on the basis of number of units change in x, correct? But do you all understand that actually y is equal to this is also the main base equation? So ideally, if x is 11 or x is 12 or x is 13 or x is 14, you could have alternatively found out y by just substituting the x in this particular equation as 11 or 12 or 13 or 14, and you could have also got y, right? Just as children here you did, right? If you remember here, when we took different levels of x, right, x is equal to 10 or 11 or 12 or 13, we simply kept substituting that x in this equation. Do you agree with me? We kept substituting x in this particular equation and we got different levels of y. And then we understood that alternatively we could have used a derivative also, which means for 1 unit of change in x, y reacts by 2 times. For 2 units change in x, y will react by 4. I'll show it to you here. See, when x goes from, okay, when x goes from 10 to 11, this is 1 unit change. Can I say y reacts by 1 derivative, that is 2 times, it is 2, basically 2 times of 1, that is by a value of 2. From 25 it goes to 27. But children, when x goes from 10 to 12, okay, when x goes from 10 to 12, 2 units change in x. Can I say y is going from 25 to 29? That is a 4 units change in y, and that 4 units change in y is nothing but, can I say, this derivative happening 2 times because x is changing by a unit of 2. Everybody clear? So basically either you calculate y using this formula or you calculate y by just applying the derivatives number of times on the base value of y. Everybody clear till here? So there are 2 ways of solving this. Similarly, in this particular example also there could have been 2 ways. One way I just showed you, that is by using the derivatives number of times. Everybody clear till here? Take the base level of y as 131. When x was 10, y was 131. Derivative we know is 23. So for every 1 unit change in x, y will react by 23. Everybody clear? 2 units change in x, y will react by 23 per unit, which means a total of 46. Everybody clear? So children, using that we did this. But I am telling you that alternatively you could have just taken this formula and also solved. So children, I want you to now see what will happen if we use this formula. Ideally both methods should come same only, right? The answer from both methods, the value of y at different levels of x, either you use the equation method or you use the derivatives method, the answer should be same as you just saw here. But let's see what happens now. Please be attentive, okay? Now, see. I'll just write down here in different ink, okay? See, we know that when x is equal to 10, y is equal to 131. This is what we got by using that equation only, the main equation. What was the equation, children? The equation was y is equal to x square plus 3x plus 1, correct? X square plus 3x plus 1. Now, if x is equal to 11, okay, if x is equal to 11, children, can I say y should be equal to 11 square plus 3 into 11 plus 1. Do you agree with me? 11 square plus 3 into 11 plus 1. So children, this becomes 121 plus 33 plus 1. Yes, this will become 155. Do you agree with me? This will become 155. So I'll just put a small bifurcation here. All right. Now, if x is equal to 12, children, please pay attention. If x is equal to 12, can I say that y should be equal to, okay, y should be equal to x raised to 2. Children, tell me, x raised to 2. 12 raised to 2 is 144 plus 3 into 12 plus 1. Everybody agreeing with me? So this will be 144 plus 36 plus 1. That will come to 181. Correct? That will come to 181. Then children, moving ahead, I'll just make the bifurcations here. Just a minute. Okay. All right. So I'll just write down here now. Okay. That if x is equal to 13, okay, if x is equal to 13, y should be equal to 13 square. See children, this 144, I hope you understand. Okay, this is 12 square, right? This is 12 square is 144. Similarly, here should be 13 square plus 3 into 13 plus 1. So children, 13 square is 169. 3 into 13 and then 1, if I take total, this should come to 209. Okay, this comes to 209, which means children, when x is 13, y is 209. And if x is equal to 14, okay, if x is equal to 14, children, do you understand that y will be equal to 14 square plus 3 into 14, correct, plus 1. So children, 14 into equal to m plus 3 into 14 m plus 1 m plus mrc, this should come to 239. Okay, this should come to 239. Are you all listening? So children, these are the values of y if we take the original formula of x and y, the quadratic equation, right? So what I will do is I'll just take these values and paste it upstairs. So when x is 11, y should be actually 155. Let's move ahead. When x is 12, y actually should be 181. Okay, so I'll write down here 181. Next children, when x is 13, y actually should be 209, correct? So I'll write down here 209. And when x is 14, y actually should be 239. Okay, y should be 239. Everybody clear till here? Now children, tell me, can you see there is a difference between example 1 and example 2? In example 1, children, whether I go with the derivative model or I go with, okay, whether I go with the derivative model by just adding 2 each time, or I simply use this particular original linear equation, doesn't matter, right? Both answers of y will come same only at all levels of x. But in this quadratic equation, children, do you understand that if I use the derivative model, that is I keep adding 23 to the levels of y for every unit change in x, the answer of y is different from what actually y will be based on this particular equation. Everybody clear? So here if you see, yes, this y, the y in blue is using the, okay, differential calculus, and this y, children, in the black is, children, based on the original quadratic equation. Now you tell me, which one do you think is the correct level of y? Obviously the one in black, the quadratic equation, is the actual level of y, right? So something went wrong in the differential calculus. Everybody clear? Something went wrong in the differential calculus, which is what I'm trying to explain to you. Please pay attention. Now children, let me show that to you here. See, what was your derivative function, children? Can I say our derivative function was, yes, 2x plus 3, correct? Our derivative function was 2x plus 3. That means for every 1 unit change in x, y will change by 2x plus 3. Everybody clear? For every 1 unit change in x, y will change by 2x plus 3. Children, when x was 10, please pay attention, when x was 10, do you realize that dy by dx came to 23? I agree. This means that when x is 10, y will change by 23 units at those levels of x which are very near to 10. Because children, if I change the x from 10 to 11, do you realize the derivative in itself also will be subjected to change, because there is x in the derivative also. Everybody clear? Unlike the previous one where there was a fixed number 2, which means for every 1 unit change in x, y will change by 2. Not 2 into x again. Everybody clear? Here what is happening, children? Here they are saying that for every 1 unit change in x, y will change by 2 into x plus 3, which means not only y is changing, but the change also will change, because there is a x here. Everybody clear? The change also will change. Not only the basic y is changing, but the degree by which y should change will also change, because children, in this 23 is the degree of change of y, but in that 23 there is a x of 10. Now I am saying if x changes from 10 to 11, then 23 is there, but this 23 also will be subjected to a slight change, because this 23 is based on x level of 10. Everybody clear? This 23 is based on x level of 10. If x is 11, then do you realize even the derivative function will change because there is x in the derivative function also. Everybody clear? So here what is happening? How is this different from the previous example? In the previous example, the change was fixed. It was a fixed constant change 2. But here the change is also variable. The change is changing. Everybody clear? I cannot say that every time for all levels of x, y will change by 23. No, this 23, this change of 23 will also keep changing because children, in the formula, the equation of the change, there is x. Everybody clear? And because of this variable component of x in the change derivative formula, the derivative keeps changing at all different levels of x. Everybody clear? Which means if I actually want to see this 23 change, then just for mathematical purpose, what you can do is from x equal to 10, you can just try if x is equal to 10 point, let's say 01, okay, or 10.1. I'll take 10.1. Okay, so if x is 10.1, children, can I say y is equal to 10.1 square plus 3 into 10.1 plus 1, correct? So children, 10.1 into equal to m plus 3 into 10.1 m plus 1 m plus MRC. This will come to 133.31, correct? 133.31. So children, 133.31 minus 131 if I do, okay, this will come to 2.31. Okay, this will come to 2.31, which means children, can you see that y changed by 2.31 when x changed by 0.1? Everybody clear? When x changed by 0.1, minute change, can I say y changed by 2.31? Which means children, I can just write it down here. Okay, see, if x is changing by 0.1, y is changing by 2.31. This means children, if x is changing by 1, y will change by cross multiplication 23.1. This 23.1, can you see slight changes there here also? Because in this also the x is changing, right? Everybody clear? So this derivative, children, is not constant. And obviously children, as you go slightly away from 10, that is 10.1, 10.2, 10.3, 10.4, slowly children, this will keep changing. Everybody clear? Because the x component is there in the derivative function. Everyone follow until here? Everyone clear? Yes. So children, therefore, this is the reason why the blue is different from the black. Everybody clear? The derivative answer is different from the actual answer because the derivative answer assumed that for every change in x, y will change by a fixed number 23. Just as it was in the first example of linear equation where y was changing by a fixed number of 2. But here children, do you understand, 23 is not a fixed number. 23 is the change in x when x is 10. I hope you're understanding. If x is 11, the difference of x from 10 to 11 is 1. So as x changes, y will change by 23, yes, but that 23 will also slightly change because that 23 is made up of an equation that is 2x plus something, right? 2x plus 3. But because that x is there in that equation of change, the change is changing. And because of that, children, as you can see, the blue line is based on this faulty assumption. But the black, children, do you realize, is the actual? And the actual, can you see that y is slightly above the derivative y? That means according to derivatives, the y should be 154, but the actual is 155. Then can you see the gap is slightly increasing? 177, but reality is 181. 200, but reality is 209. And then children, 223, reality is 239. So children, if I actually want to plot this black data, the actual data, so let's say, okay, let's say that this is 10 here, okay, let's say this is 10 here, okay, and therefore this here is 131. So children, we drew this straight line based on the blue coordinates, but if I just take the black coordinates for y, do you understand, they will slightly start going far away from the blue line. Everybody clear? They'll start going slightly away from the blue line because as you are going farther away from x, the change in y will be more and more than 23. This blue line, children, is made on the basis of a 23 unit change for every 1 unit change in x. But actually, as I told you, the change also will keep changing as the x changes. And as the x goes farther away from this base, yes, this is the base here that we have taken, correct? This is the base. Yes, I'll just draw this base in a blue line so that it makes a lot of sense to you. Okay, so this is the base here. All right, and now can you see the difference in that black line? And obviously, children, if you go downstairs also, which means if you take x as 9, 8, 7, 6, 5, then also if you make the coordinates, okay, both with the blue y and the black y, that is using the derivatives as well as using the equation, then also, children, this will keep going away and away like this. Yes, the difference will be visible. This is called as convexity. Everybody clear? This is called as convexity. This is what I wanted to explain to you as far as mathematics is concerned. Yes, children, in mathematics, there is intense level of mathematics where you can, listen to me carefully, you can also get this particular blue y exactly equal to the black y by using second derivative and so on. I am not going into that. But this gap, children, correct? This blue line can also fit with the black line if you do not stop at the first derivative and you go for the second derivative, the third derivative and so on. Slowly, this gap will start bridging itself. Okay, the gap will start bridging itself. So children, let me just tell you that in the next videos coming up, when we end this particular module of convexity, bond convexity, at the last I will just tell you that yes, somewhere in our explanations earlier, I'll tell you now only, volatility, you remember there was a concept of duration and volatility. In that, the concept of volatility, children, was the first derivative, and convexity is like the second derivative in practice. So children, from the mathematical point of view, yes, we are going to be applying the second derivative, but how that derivative is applied, the derivation of the derivative, children, we are not going to go into that. I'll of course be showing you the formula at the end. I'll explain everything to you till the first derivative, and beyond the first derivative, how to go from first derivative to second derivative, which means how to bridge this gap, etc. There is a formula. We will take it and complete it. Everybody clear? So now that you have understood the basics of differential calculus, that is this mathematical derivatives, now let's come back to SFM. Children, in SFM we had studied a concept called as duration and volatility. In this particular video, I will be discussing something about duration, and I'll help you create a mathematical equation for duration. So before we do that, children, by the way, do you all understand we are in which module? We are in a module called as bond convexity. What convexity is all about, I have not yet taught you, but I have shown you a small glimpse of what it is, that convexity on a graph, when I taught you derivatives in the previous video. Now children, to understand convexity in a bond scenario, first of all I am taking up this video where I will be teaching you mathematical equation for the concept of duration, and for that, children, I will just take one small example to just, refresh your memory as far as what duration was all about. Can we start? So children, let's take an example. I'll write down here duration. Okay, duration. Now children, in duration, if you remember, it was the weighted average payback period of a bond. So I'll take an example here. See, let's say face value of a bond is ₹1000. Coupon rate is, let's say, children, 10%. Redemption value is at par, and number of years are 3. Okay, number of years are 3, and children, YTM is, let's say, 12%. Okay, YTM is 12%. Now how do we calculate duration? If you remember, okay, calculation of duration, for this, children, we make a table in which the columns are as follows. There is year, there is cash inflow, there is discounting factor at the rate 12%, there is present value. Now children, if you discount the future cash flows at the rate YTM, the total of the present value is obviously the current market price of the bond. I hope you remember that. Then children, we have something called as weights, and then we have year into weights. This was the first method I taught you in duration. Then I told you ICEA has one more method, and we have solved many questions based on the ICEA method only. But to explain this particular equation, what I want to teach you, so that you understand something, so that you understand something, so that you understand bond convexity, for that I am taking this first model of calculating duration. Okay, so children, this we have discussed in detail in the past. I'm just now not going into the details of the concept here, just showing you the numbers here. So children, in here we'll write down 1, 2 and 3. In cash inflows, children, do you understand that this particular bond, 1000 rupees is the face value and coupon rate is 10%. So children, 100, and then considering redemption is also at par, that is 1000 plus 100, that is 1100 is the final cash flow. Now discounting factor at the rate 12%, 1 divided by 1.12, okay, this will be 0.8923, okay, 0.8929, okay, 0.8929, not 23, 0.8929. Then we have got 0.7972, and then we have got 0.7118, okay, 0.7118. So children, if we take the present value, this will come, total comes to the current market price. So children, this is 100 into 0.8929 M plus, so this is 89.29. Then there is 100 into 0.7972 M plus, this is 79.72, and there is 1100 multiplied by 0.7118 M plus, this is 782.98, and we do MRC, this comes to 951, okay, 0.99 or 952 basically. Okay, so children, this becomes your current market price. Now as far as the weights are concerned, children, weights, how do I calculate weights? 89.29 divided by 951.99, this is 0.09. I'll write down here 0.09. Then children, we have 79.72 divided by 951.99, okay, so this is 0.08, okay, and then 782.98 divided by 951.99, we have a weight of 0.82, okay, 0.82. Yes, so children, the total of the weights is 1. Okay, total of weights is 1. Of course, children, for the exact number, we can just add 0.01 here. Yes, so this is 0.83, and therefore, children, you get your total of weights as 1. Otherwise, it would have been 0.99, rounding off difference. Okay, so children, if we do year into weights, okay, so 1 into 0.09 M plus, 2 into 0.08 M plus, 3 into 0.83 M plus, MRC, it comes to 2.74 years. Okay, 2.74 years, and this, children, was the duration, correct? Which means we say that this particular project or this particular bond is repaying our initial investment of 952 rupees in 2.74 years. Everyone follow until here. So now, children, this was what was duration. Let me now just place the entire thing in an equation form for you, and that will be the end of this video. Okay, so children, calculation of duration, I'll write down here again, calculation of duration. Okay, now what I'm going to do is, I'll first of all take the first 4 columns only. Okay, year, cash inflow, discounting factor and PV. Okay, so I'm writing here year, cash inflow, discounting factor at the rate 12%, children, is nothing but YTM. Everybody agreeing with me? And then we have got present value, correct? So YTM I'm writing as Y. Children, in year 1, what is the cash inflow? Can I say the cash inflow is interest at the end of year 1? What is the discounting factor? Can I say discounting factor will be 1 divided by 1 plus Y raised to 1. Everybody clear? Similarly, children, tell me what will be year 2? Year 2, can I say the cash inflow will be interest of year 2, and the discounting factor will be 1 divided by 1 plus Y raised to 2. Third year, children, Please be attentive. Third year, do you realize the cash inflow will be I3 plus redemption value, correct? Interest at the end of year 3 plus RV, and the discounting factor will be 1 divided by 1 plus Y raised to 3. Everyone follow until here, and therefore the present value, children, is nothing but cash inflow into discounting factor, which is I1 upon 1 plus Y raised to 1. This is I2 divided by 1 plus Y raised to 2, and then we have got I3 plus RV, okay, I3 plus RV, the whole upon 1 plus Y raised to 3. So these are the present values, and we all know that the total of the present values is the current market price, because the discounting of future cash flows has been done at YTM. This current market price, children, I will be referring it as capital P. Everybody clear? So capital P is the price of the bond, the actual current market price of the bond. Great. So with that, students, you can see we have reached column number 4, and now column 4, 5 and 6 I will take it in a separate table because there was no space there. So that is why I'm breaking the table into two parts. So first part was the first 4 columns, and then the second part will be 4th, 5th and 6th column. Can we start? So PV, weights and year into weights. So I'll write down here PV, weights and then year into weights. Can we start? So children, as far as PV is concerned, we already have that. Okay, it is I1 upon 1 plus Y raised to 1. So I'll write down here I1 upon 1 plus Y raised to 1. Second, children, we have I2 upon 1 plus Y raised to 2. So I'll write down here I2 upon 1 plus Y raised to 2. And the third, we have I3 plus RV. Okay, I'll write down here I3 plus RV, the whole upon 1 plus Y raised to 3. Everybody clear? And the total, children, obviously is the price. Now, how do I calculate weights, children? Any idea? How should I calculate weights? Very simple. Weights will be nothing but, see, it is nothing but the first term divided by price, then the second term divided by price, and then the third term divided by price. Everybody clear? That will give you the weights. So let's do that, children. So this will be I1 divided by 1 plus Y raised to 1, the whole upon P. This is the weight for the first term. Then, children, the weight for the second term will be I2 divided by 1 plus Y raised to 2, the whole divided by P, correct? And the third will be I3 plus RV, okay, the whole divided by 1 plus Y raised to 3, the whole divided by P. Everybody clear? And the total of the weights obviously will be 1. Children, everyone follow until here. And the last now, year into weights. So children, we know the first term year is 1. So do you realize this is 1 into this weights, that is 1 I1 divided by 1 plus Y raised to 1, the whole divided by P. Then, children, the second year will be 2 into the second year weight. So 2I2, correct, divided by 1 plus Y raised to 2, the whole upon P. And then the third year will be 3 into its weight. So 3 bracket I3 plus RV divided by 1 plus Y raised to 3, the whole divided by P. And the total of this all is obviously the duration of a 3-year bond. Everybody clear? The total is nothing but the duration. Everyone understands till here? Okay. Now, so let me now take this outside. Okay. So can I say that therefore duration, okay, duration of a 3-year bond, okay, duration of a 3-year bond, I'll write it as D3, is equal to the sum of the last column, right? So the first term is 1I1, okay, I'll write down 1I1 divided by 1 plus Y raised to 1, the whole divided by P. So I'll write down here 1I1, the whole divided by 1 plus Y raised to 1, the whole divided by P. Everybody clear? This is the first term. Plus, children, the second term is what? 2I2 divided by 1 plus Y raised to 2, the whole divided by P. So I'll write down here plus 2I2 divided by 1 plus Y raised to 2, the whole divided by P. Everybody clear till here? Plus the third term, children, the third term is 3 bracket I3 plus RV the whole divided by 1 plus y raised to 3 the whole divided by p. Children, so I'll write down here 3, okay, I3 plus RV, okay, divided by 1 plus y raised to 3 the whole divided by p. Do you agree with me till here? So therefore children, I can say that duration of a 3-year bond is nothing but, what I will do, 1 I1 upon 1 plus y raised to 1 plus 2 I2 upon 1 plus y raised to 2 plus 3. Children, I3 plus RV divided by 1 plus y raised to 3. Children, can I say the whole divided by p? This becomes the duration of a 3-year bond. Everyone following till here? And if this is the duration of a 3-year bond, can I say that therefore duration, okay, duration of a n year bond, okay, duration of a n year bond will be how much? So children, this is dn, okay, will be equal to, I just write down a colon here, okay, this will be nothing but 1 I1 upon 1 plus y raised to 1 plus 2 I2 upon 1 plus y raised to 2 plus 3 I3. Redemption is not happening at end of year 3, okay, it can happen at end of year 5, 6, 10, whatever. So upon 1 plus y raised to 3 plus dot 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 n, everybody following, bracket I n plus rv, okay, the whole divided by 1 plus y raised to n, and then the whole divided by, okay, I'll take a scale here, the whole divided by p. Everybody clear? The whole divided by p. So children, this is the formula of a duration of a n year bond. Everybody clear? So I'll just put this in a box here, okay, I'll put this in a box, and with that children we end this video here, okay. As of now, why we have done this you will not understand, but as the videos and the concept progresses and as we progress towards bond convexity, you will understand everything, why we are doing what we are doing, okay. So children, with that we end this particular video, where at the end of this video I have given to you an equation for the duration of n year bond. I hope you understood this video till here. So now that we have completed our discussion on the duration part, let us now further our discussion on the volatility part. But before we go to that volatility mathematical derivation, students, let us first of all refresh our memory on what we know about volatility. Can we start? So children, I'll just write down here volatility, okay, volatility. Now children, volatility, which we used to write as capital V, the formula that I had taught you was duration. Yes, V is equal to duration divided by 1 plus YTM. Do you remember this? Duration divided by 1 plus YTM. And this indicates, okay, I'll write down here, this indicates percentage change in current market price for every 1% change in YTM, okay, for every 1% change in YTM. I hope you remember the entire discussion of volatility. Let us apply this formula in our previous example. Now in the previous example, if you remember, we had calculated duration as 2.74 years, correct? 2.74 years. Let us calculate the volatility for the same. So children, can I say V is equal to 2.74 years divided by 1 plus yield. Children, the YTM year was 12%, so I'll just write down here 1.12. If I take my calci, 2.74 divided by 1.12, this will come to 2.45. So I'll write down here 2.45. Children, what is 2.45? I'll write down here, okay. This means that current market price will change by 2.45% for every 1% change in YTM. Everybody following? So for every 1% change in YTM, price will change by 2.45%. I'm very sure you remember it's an inverse relationship, right? Which means if YTM increases, price will fall. If YTM falls, price will rise. I hope you remember that, right? So children, this was the discussion that we had done in volatility. Yes. Now children, let us understand the derivation of volatility. Very interesting it is. Please be very, very, very attentive. Okay, let's start. So children, see, you all know that current market price of a bond is nothing but present value of all future cash inflows discounted at the rate YTM. Do you remember this? Great. So children, the first cash flow will be I1, okay, divided by 1 plus y raised to 1, that is discounting for 1 year at the rate YTM. Like that, I2 divided by 1 plus YTM raised to 2, okay, so 1 plus y raised to 2. Then children, we have I3, I4 and so on till IN. So what I will do is plus dot 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 dot, children, IN plus RV, correct, redemption also will get at the end of life, the whole divided by 1 plus y raised to n. Everybody agreeing with me till here? Now children, I'm pretty sure you know mathematics and therefore you should understand this, that current market price is equal to, now children, I will do I1 into 1 plus y raised to minus 1. Do you understand this? Children, I hope you understand all this. This was taught to you in your maths, in your childhood indices and all. Don't expect me to teach you all this. So children, when there is something raised to minus 1, it means it has to be taken in the denominator. So if it is there in the denominator, it will be going in the numerator with a minus 1 in the power, right? So plus, children, this will be I2 into 1 plus yield raised to minus 2. Now plus dot 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 IN plus RV, okay, IN plus RV into 1 plus y raised to minus n. Everybody clear till here? Children, this what you see on the screens, this last equation, okay, this equation children is a relationship between two variables. Which two variables children? The variables are current market price and yield, okay, current market price and yield. The I1, I2, they are all constants. I hope you understand. Children, can I say yield and CMP are variables where yield is the independent variable and CMP therefore is the dependent variable, which means with every unit change of y, that is yield, CMP will definitely change. Everybody clear? We have seen in the past, right? In the previous videos we have seen a linear equation, a quadratic equation. Similarly, this is also a much bigger equation, but you can see the underlying thread principle is that there are two variables, one is dependent on the other, just like there was x and y, two variables there where y was dependent on x. Similarly, here there are two variables, yes, yield and CMP, where the CMP is dependent on yield. Everybody clear till here? So I'll just remove the markings now, okay, I'll remove the markings. Children, I now want to know that if there are two variables which are having this relationship in this big equation, I want to know by how much, okay, by how much will CMP fluctuate, okay, by how much will CMP fluctuate for every 1 unit change in YTM. And children, this y of course is nothing but YTM. Everybody clear? This y is nothing but YTM. So what they are asking you, for every 1 unit change in YTM, now unit of YTM means the percentage only, I'll call it as unit as of now. For every 1 unit change in YTM, by how much will the current market price change? Children, this is hinting towards that same derivatives which I taught you 2-3 videos back. Do you understand that here the two variables, which is CMP and YTM, who is the dependent variable here? Can I say CMP is the dependent variable and YTM is the independent variable, and therefore children, I'm pretty sure you understand they are asking you dCMP divided by dyTM. Everybody following? They're asking you dCMP upon dyTM. That is, for every 1 unit change in YTM, what is the value of change in current market price. Everybody clear? This is not 1 unit, okay? This is the number of units change in current market price for every 1 unit change in YTM. This is the entire structure. And to make things very simple for you, this thing, okay, can be written as dp upon dy. That's it, correct? dp upon dy, that is change in price upon every 1 unit change in yield. Everybody following till here? Okay, so students, this is dp, that is change in cmp, and this is dy, that is 1 unit change in YTM. Everyone following till here? So students, let us now apply the differential calculus on this particular equation. Let's start. So children, we all know, okay, that this cmp can be written as p only, right? So I hope you understand, this is p, the dependent variable. So now I am doing dp by dy. Can we start? dp by dy. So I'll write down here dp by dy is equal to, I'll again repeat, what is dp? dp is the value of change in price. dy is what? 1 unit change in YTM, that is yield, okay, is equal to. Now how do I apply the differential here? Students, focus here please. Everyone focus on this part here. Children, in this part the I1 will remain I1 only, so I'll just write down here I1 into, now children, do you understand 1 plus y raised to minus 1? How do I take a differential here? How do I apply the derivatives rule here? Can I say this minus 1 will come down? So I'll write down here into minus 1 into, and now children, this is 1 plus y raised to minus 1 minus 1. Everybody clear? I hope you remember the first video of derivatives in this module of bond convexity. So I'll write down here into 1 plus y raised to minus 1 minus 1. Everybody clear? Plus, children, as far as the second term is concerned, okay, as far as the second term is concerned, I'll just mark it for you. Okay, this term here, tell me what to do. I2 will remain I2 only, so I'll write down here, okay, I'll write down here I2 into. Now children, tell me what to do. Can I say this minus 2 will come down, and then it will be into 1 plus y raised to minus 2 minus 1, correct? So I'll write down into minus 2 into 1 plus y raised to minus 2 minus 1. Everyone clear? Plus dot 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 dot. So children, the last term we will take now. The last term is this one. I'll mark it for you children. This term is the last one. So tell me students, what to do here? Children, do you realize that in plus rv will remain same? So I'll write down here, okay, plus in plus rv, this won't change. Now do you realize into this minus n will come down, so it will be minus n into 1 plus y raised to minus n minus 1. Everybody following? So here I will do into minus n, okay, into 1 plus y raised to minus n minus 1. Everyone following? So let's now make this entire equation a bit more smooth. So I'll do dp upon dy is equal to, children, I1 into minus 1 will be minus 1 I1, and then 1 plus y raised to minus 1 minus 1 will be minus 2, and 1 plus y raised to minus 2 is nothing but 1 upon 1 plus y raised to 2. Everybody clear? So I'll just divide this by 1 plus y raised to 2. Plus, children, I2 into minus 2 will be minus 2 I2, and then 1 plus y raised to minus 3 will go downstairs as 1 plus y raised to 3. Plus dot 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 dot, children, minus n into in plus rv will be minus n, okay, I'll write down here plus dot 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 dot, dot minus n in plus rv, okay, divided by, I'm pretty sure you understand now, 1 plus y raised to minus n minus 1 can be taken in the denominator as 1 plus y raised to n plus 1. Everybody clear? Raised to n plus 1. So now children, this is one smooth equation that we have got. Children, tell me now what can we do next? What I propose is, from the LHS, the dy that we have, okay, from the LHS, the dy that we have, let us push it to the RHS. So children, can I say dp will be equal to minus 1I1 upon 1 plus y raised to 2. Okay, I'll just make it correct here. Okay, plus minus 2I2 upon 1 plus y raised to 3 plus dot minus n I n plus rv the whole upon 1 plus y raised to n plus 1, and this whole thing, children, multiplied by dy. Everyone clear with this? Now in this bracket, if you see, I can take out common minus 1 upon 1 plus y, and let's see what happens. Okay, so I'll just write down here dp is equal to, I am taking what common, children? Minus 1 upon 1 plus y I am taking common. Okay, minus 1 upon 1 plus y if we take common. So now, children, tell me what will happen now. Do you understand that here I will have I1 upon 1 plus y raised to 1? Everybody clear? Plus 2I2 upon 1 plus y raised to 2. I hope you are understanding maths. Okay, from the denominator 1 plus y raised to 1 is taken common, and the numerator minus 1 is taken outside, plus n bracket in plus rv the whole divided by 1 plus y, now raised to n only, not n plus 1, the whole into dy. Everybody clear with this? At this stage, children, going forward, dividing both LHS and RHS by current market price, that is P. So on both sides, if I divide by P, it is correct. So children, on both sides I am dividing by P. What will happen? On the LHS it will become dP upon P. So I'll write down here dP upon P is equal to, okay, dP upon P is equal to minus 1 upon 1 plus y, okay, minus 1 upon 1 plus y into I1 upon 1 plus y raised to 1 plus 2I2 divided by 1 plus y raised to 2 plus n in plus rv the whole divided by 1 plus y raised to n. Correct? So children, this entire thing is in bracket, so I close the bracket here and I multiply by dy, and this whole thing, children, do you understand, will be divided by p. Okay, this whole thing will now be divided by p. So I'll just mark a line here and I'll write down p. Everybody clear? We have divided both the LHS and RHS by p. Now children, please understand that this is your one term. Let me just mark it for you. This is one term, this is second term, and this is third term divided by fourth term. Correct? Now let me just see how many of you understand mathematics. See, children, do you understand that if it is a into b into c divided by d, this can also be written as a into b by d into c? Do you have any problem with that? Of course not, it's the same answer, right? So similarly, children, here do you understand this is like a into b into c divided by d. So what I'm going to do is I'm going to take b by t on one side and a and c separately, but doesn't matter, the answer will remain same, right? So children, what I will do now is I'll just write down here dp by p is equal to minus 1 upon 1 plus y into, now children, this particular bracket I1 upon 1 plus y raised to 1. This I1, children, can I say I can write it as 1 I1 also, doesn't matter, correct? Because this 1 is there, not there, doesn't matter. So just write down here 1 I1 upon 1 plus y raised to 1 plus 2 I2 upon 1 plus y raised to 2 plus n in plus rv the whole upon 1 plus y raised to n. Okay, this bracket I close, and then below this bracket, children, okay, below this bracket I just divide by p, and then I write into dy. Everybody clear? Into dy. Everyone following till here? Now children, what can happen? See, dp upon p is equal to minus 1 upon 1 plus y into dy, not changing anything here, but now this central term here, this one, okay, that we did as b upon d. Children, have you seen this somewhere? Yes, of course you have seen it. I'll show it to you, children. We had studied this in the duration model. Do you remember this entire equation? This is exactly that equation, duration of n years. Yes, duration of n years, this was the entire equation. So therefore, children, instead of this entire area here, this red marking, what we can do is, instead of that, we can simply write it as duration. Everybody clear? We can simply write it as duration. So children, therefore, what do you understand? That dp upon p is equal to minus 1 upon 1 plus y into d into dy, where d is the duration for n years. Everybody clear till here? Great. Now one term please try understanding. Okay, see children, what is dp? dp, if you remember, was the change in price of the bond, correct? Delta of cmp, change in cmp. So children, do you understand that I can write it something like this, that delta cmp divided by p, children, can I say is nothing but cmp only? Everybody clear? P is nothing but cmp, is equal to, children, minus 1 into d, can I say, can be written as minus d upon 1 plus y multiplied by dy. Children, dy refers to 1 unit delta in YTM. I hope you remember, right? It refers to 1 unit delta in YTM. Now, on the LHS, children, on the LHS, delta CMP upon CMP is nothing but percentage change in CMP. Do you understand? Delta CMP, change in price upon price, is nothing but the percentage change in price, is equal to minus d upon 1 plus y into, children, what is 1 unit of yield or YTM? It is 1%, right? It is not some rupees or kilograms. It is percent. So children, can I say, I'll write down here 1% change in YTM. Okay, 1% change in YTM. Now children, this 1% change in YTM, let us take it to the LHS. Can I say therefore percentage change in CMP upon percentage or 1% change in YTM is equal to minus d upon 1 plus y? Everyone following? And now on the LHS, if you see, what is it all about? For every 1% change in YTM, what is the percentage change in CMP? This is nothing but volatility. Everybody clear? This is nothing but volatility. Bracket V is equal to minus d upon 1 plus y, and d upon 1 plus y is nothing but duration, okay, divided by 1 plus YTM. This is what we have learned, right? Duration upon 1 plus YTM. Now children, you must be feeling what this minus sign is. Don't worry much about it. The minus sign is all about telling you one thing, that the yield and the CMP have inverse relationship. That's it. The volatility is negative means what? For every 1% change in YTM, CMP will change by this much percent in the opposite direction. Everybody clear? That's it. So with that children, I just explained to you what is the derivation of volatility, and therefore do you all understand that volatility is nothing but dp by dy, that is nothing but our first derivative. Everybody clear? It is nothing but our first derivative, which I showed you in the first video of derivatives also of this particular module, where I taught you the mathematical derivatives, the differential calculus of what does first derivative mean. First derivative is nothing but that same thing which we have been seeing now, applying dy by dx, or here dp by dy, that is the first derivative. It simply shows for every 1 unit change in YTM, or for every 1% change in YTM, what is the change in price. Everyone following till here? So welcome to this video where we will be finally understanding the convexity of a bond. For the same, I will be continuing this example which I had given to you some time back, where children, we had calculated the duration as 2.74 years and the current market price had come to 951.99, rounded off to 952. So children, we have a bond whose CMP is 952, the duration is 2.74 years, and the volatility is 2.45. Now what does 2.45 means? This means that CMP will change by 2.45% for every 1% change in YTM. Inverse relation, right? That is, if the YTM goes up by 1%, the bond price will drop by 2.45%. If the YTM drops by 1%, the bond price will go up by 2.45% for every 1 unit of change in YTM. So this was as far as volatility was concerned, and we also saw that this is nothing but the first derivative, correct? This is nothing but the first derivative, as I showed you the entire derivation for the same. Yes, V is nothing but dP by dy. Change in the price of the bond for every 1% unit change in the yield. Everyone clear till here? So now students, coming to convexity. Now please pay attention. Okay, see, I'll write down here YTM. Children, YTM, can I say, is the independent variable on the basis of which we get the dependent variable, that is CMP. Now at a YTM of 12%, children, can I say that the CMP that we got, okay, the CMP that we got was 952, correct? 952 was the CMP that we got. So I'll just write down here 952. Everyone agreeing with me till here? Great. Now children, I want you to be extremely attentive. Please pay attention. Do you understand that if YTM goes to 13%, the current market price will change? Now, according to the formula of volatility and the derivation that we got, we have the volatility of this particular bond as 2.45, right? That means for every 1% change in YTM, the bond price will change by 2.45%. So students, do you understand that if YTM increases by 1%, that is from 12% to 13%, current market price should now drop by 2.45% into 1 because only 1% drop in YTM. So children, 952 minus 2.45%, if you do, yes, 952 minus 2.45%, the answer comes to 928.7. okay, 928.7. Children, how did I get 928.7? Very simple. I just did, okay, if YTM increases by 1%, that is, it goes to 13%, can I say current market price, which was earlier 952 when the YTM was 12, from there, can I say it will drop by 2.45% into 1. Everyone follow until here, and that will come to 928.7. Everyone clear? Now let's move ahead, children. Let's move ahead. What if, okay, if YTM increases by 2%, that is, if it goes to 14%, everybody clear? Which means from 12, if it jumps 2% to 14, then according to the derivative, that is, it is saying that for every 1% change in YTM, there is a 2.45% change in the price of the bond. Do you realize that the current market price should be 952 minus 2.45% into 2, right? Into 2, because for 1% change in YTM, there is a 2.45% change in price. So for 2% change in YTM, there will be a 2.45% into 2. Yes, that is the change, percentage change in the price. So 2.45 into 2, children, is 4.9%. So 952 minus 4.9%, if we do, we will get 905.35. okay, 905.35. So I'll just write down here 905.35. okay, 905.35. Children, moving on, what if YTM goes up to 15%? Okay, so I'll just make the bifurcations here. All right. So children, if YTM goes up to 15%, okay, if YTM goes up to 15%, I'll write down here, if YTM increases by 3%, right, from 12% to 15, so that is 15%. Do you realize, according to the derivative, the current market price should be 952 and it should drop by 2.45% 3 times, correct? So I'll just write down here minus 2.45% into 3. So on the calci, children, 2.45 into 3 is 7.35% drop. So 952 minus 7.35% will give you 882.0. Okay, 02 or 03. So I'll just write down here 882.03. So the current market price should be 882.03. I'll write down here 882.03. Children, last one more I'll take, 16%. Okay, if YTM is 16%, that is, it jumps up by 4% from 12%. So if YTM jumps by 4%, that is, it goes to 16%. Can I say the current market price should drop by 2.45% 4 times from 952? So I'll write down here 2.45% into 4. Okay, so 2.45 into 4, if we do, children, it comes to 9.8%. So 952 minus 9.8% will give us 858.7. Yes, so this I'll write it down here, 858.8. 858.8. Everyone following? 858.7. Okay, I'll write down here 858.7. Now children, if I plot these coordinates on a graph, they will form a straight line. Okay, they will form a straight line. So I'll just draw the graph downstairs here. Please be attentive. This is the y-axis, okay, and this is the x-axis here. All right, so this is the graph here, children. On the y-axis I'll just write down current market price, and on the x-axis I will write down YTM. Okay, and children, if we plot it on a graph, all those coordinates, you can try it out later, but right now just trust me, if we do it, it will form part of a straight line like this. Now children, your question would be, why is the line like this? Why is it not like this, like you showed last time in the derivatives video? Because children, here what is happening is, as your YTM increases, can I say current market price decreases, right? It is not increasing. So as YTM increases, current market price decreases, which is why the line is tilting in this fashion. Everyone clear with this? Okay, so now children, now this particular graph that you see here will happen if x and y both are going in the same direction, which means when x increases, y also increases. If x decreases, y also decreases, then this is right. But if they are going in the inverse fashion, that it means if one increases, the other decreases, then this is how the line will appear. Everyone clear? And children, the central point here, okay, central point here is when YTM is 12%. So children, what I will do is, I will just mark here, okay. So I'll just mark here, this is that coordinate, okay, and here I will just mark as 12%, and at 12%, children, the current market price, okay, we had got is 952, correct? 952. So I'll just write down here 952. Everyone clear till here? Now children, these coordinates were plotted based on, okay, based on what the current market price would be if the derivative function is perfect. Everybody clear? If the derivative function is perfect, then children, these market prices are perfect. But children, as you know, that there are always two ways of finding the CMP now, or the dependent variable. One was using the derivative function, and one, children, is using the actual equation. Everybody following? One is using the derivative function, one is using the actual equation. So I'll write down here actual equation. Actual equation means CMP is equal to present value of all future cash inflows discounted at the rate YTM, and as per derivatives means you just saw. I'll write down here as per the derivative function, which means they are saying that the bond price will change by 2.45% for every 1% change in YTM. That we have received. Now let us calculate based on the actual equation. So children, this of course is 952, there is no doubt about it. But when we change, okay, from 12%, if it goes to 13%, let's calculate. So students, do you realize these are your cash flows? Now we have to discount them at 13%. So what we will do is 100 divided by 1.13 equal to m plus, equal to m plus, equal to m plus, and then 1000 divided by 1.13, 123 equal to m plus MRC. This comes to 929.17. Okay, 929.17. So I'll just write down here 929.17. 929.17. Okay, 929.17. Everybody follow until here? Next, children, at 14%. Children, if you do the discounting at 14%, 100 divided by 1.14 equal to m plus equal to m plus equal to m plus 1000 divided by 1.14123 equal to m plus MRC 903.13. Okay, 907.13. It comes to 907.13. So I'll write down here 907.13. Next, children, at 15%, let's do the discounting at 15%. 100 divided by 1.15 equal to m plus equal to m plus equal to m plus 1000 divided by 1.15 123 equal to m plus MRC 858.84. So I'll write down 885.84. Sorry, it is 885.84. So I'll write down here 885.84. Okay, 885.84. And at 16%, children, at 16%, I'll just do the calculation. 100 divided by 1.16 123,000 divided by 1.16 123, and this comes to 865.25. Okay, 865.25. So I'll write down here 865.25. Now, children, can you see here that the actual current market prices are slightly different from what the derivative function was promising us? Everybody clear? They are slightly different. Why is there a difference? And can you see the difference is slowly increasing? Everyone, can you see the distance is slowly increasing? 928.7, 929, minor difference. 905.35, 907, that is a 2 difference. 882, 885, almost 3.8 difference. 858 and 865, this is around 7 difference. Children, do you realize that as the YTM is going from 12 to 13 to 14 to 15 to 16, the actual market prices are slightly higher, and the gap is increasing over and above what the derivative was promising, and therefore this graph that we have drawn as per what the derivative was promising, do you realize the actual market prices are slightly above? Everybody clear? The actual market prices are slightly above. Similarly, children, if you go below in a sense, if you try calculating at YTMs below 12 as 11% or 10% or 9% or 8% or 7%, then also, children, do you realize that there will be this curve here? Okay, the actual market prices will be slightly like this. Everyone following? This, children, is what is called as convexity of bond. Everybody clear? This convex shape, if you see, the black line is the actual bond prices, right? And the blue line is the line as per the volatility, that is the first derivative. So, children, the first derivative, as you know, has been giving you a slightly wrong answer because of one reason. Let me explain to you. But before I tell you that reason, do you understand why it is slightly wrong? Because the first derivative is assuming a linear line, but in reality the line is curvilinear. Everybody clear? And this curve is called as the convexity of the bond. Now, children, if you remember, okay, if you remember this explanation I had given to you in the derivatives also, in which I told you that this distance here, this happens because the change, the derivative also changes, right? Here, if you remember, 23, right? 23 was the first derivative, but I told you that this change of 23 also is subjected to change. Why, children? This because the derivative in itself included the variable x. Everybody following? And therefore, for every change in x, y will change by 2x plus 3. But, children, do you realize that x is changing, and therefore the change of 2x plus 3 is also changing? Similarly, here, children, do you realize the first derivative, the volatility that we took? Yes, the formula is duration upon 1 plus YTM, or to be very clear, after the whole thing, if you remember, we had got it as d upon 1 plus y. So, children, I am saying that for every 1% change in yield, correct, the bond price will change by d upon 1 plus yield. But do you realize that in this first derivative formula of d upon 1 plus y, there is that variable y? So for every change in y, do you realize this change of volatility also is subjected to change? It is not fixed, which means this 2.45% that we had got earlier as the volatility with which we were changing all the prices, that is not fixed. It will keep changing, because as the yield changes, children, do you realize this change, this volatility also will be changing, which is why, children, there is this difference between the black and the blue line. Had the volatility been fixed or constant, then, children, the line would have been linear. The black line would have been as straight as the blue line. But because that volatility includes YTM, the variable, so with every change in YTM, the volatility is also changing, and which is why, children, the reality is slightly different from that. So 2.45, yes, 2.45 is the volatility at 12% YTM, but at 13, at 14, at 15, this 2.45 also will be changing, right? It will keep changing at every unit change in YTM, and therefore, children, that assumption that 2.45% change will be fixed throughout is slightly wrong, which is why the blue line is slightly wrong and the black curve is the right curve. And this curve, children, is called as the convexity of the bond. Everybody clear? So now, children, in the next video, I will be just giving you one formula which is nothing but second derivative, third derivative, which will be applied on the first derivative of volatility. So the first derivative of volatility, on that there is a lot of mathematics which is done, and that is therefore changed and brought out as a new formula called as convexity, because volatility, children, will take you on the blue line, but the convexity formula will remove you from the blue line and exactly attach you on the curve. Everybody clear? And therefore, children, if that happens, then do you realize these two values should also be same? Everybody clear? See, this value is obviously as per the equation, but this is something that we need to modify, because here in this particular column we have taken only one derivative, assuming that 2.45 to be a constant change. But no, that change is also variable, right? The change keeps changing, and therefore we need a new formula, a second derivative, a more advanced derivative, so that we will be able to get this column also exactly equal to this column. So in this particular video, now we will finally look at the convexity formula and its impact on the current market price of the debenture or the bond at every given change in YTM. Children, if you remember this table, the blue numbers, the blue figures are the figures as per the derivative function, that is as per the volatility, that is the first derivative. And then, children, we saw that if you actually calculate the current market price as the present value of all future cash inflows discounted at the rate YTM, then the black figures will appear, and the black figures, children, obviously are the correct ones. The blue ones are slightly faulty, and that fault, children, can be seen in this graph here, that is the convexity. Everybody clear? So, children, do you understand that this particular curve that you see here, the black one, is the convexity, and children, that gap is what we have to fill now. Everyone clear with this? The blue line is as per the volatility of the bond. Now, if you remember, in the previous video we showed that the volatility of this bond was 2.45% for every 1% change in YTM. So if that volatility is fixed for every change in YTM, then, children, the bond prices will fall on that blue line. But as I told you, the volatility also is subjected to change at different levels of YTM, and therefore the actual graph is this black curve. Now, children, we have to find out a way to bridge this gap between the blue and the black lines as and when the YTM changes, which is why we have the convexity formulas. Okay, so, children, before I show you the formulas, let me just take any one example with the help of which I'll explain to you the entire understanding. Okay, so now, children, first of all, do you all remember that the volatility of this particular bond was 2.45%? I'll just write down here 2.45%, okay, was the volatility of this bond. Children, what I would want to do is, I'll just remove these markings here, okay, and just follow what I'm doing, and then you'll understand everything. Okay, see. Now, children, I hope you remember that 12% was the base, right? The actual YTM was 12% today, and then we did calculate for 13, 14, 15 and 16. Now, I just want to calculate the current market price at one more rate of YTM, 10%. Okay, 10%. Why? I'll tell you in some time. Right now I'm taking it as 10%. So children, if the YTM is 10%, now what should be the market price as per the derivative function? Children, as per the derivative function, the market price should be, children, the current market price, that is 952, and then children there will be a change as per the derivative of 2.45% for every 1% change. So children, 2.45 for every 1% change from 12, if it is dropping to 10, do you realize there is a 2% change in the YTM? So 2.45 into 2, there should be a 4.9% change in the current market price. Children, so therefore my current market price is 952. Considering that the YTM is falling, do you realize the price should increase, correct? It's an inverse relationship. So 952 plus 4.9%, okay, will give you 998.6. So I'll write down here 998.6. In reality, children, let us do the calculation. So discounting future cash flows at 10%. So 100 divided by 1.1 equal to M plus equal to M plus equal to M plus 1000 divided by 1.1, 1, 2, 3 M plus MRC. This comes to rupees 1000. Of course, the coupon rate is also 10%, discounting rate also 10%. So it will give you the par value, that is 1000. Everyone clear till here? Great. So now children, I will just remove these markings here. Okay, can you also see, first of all children, that as far as the 10% is concerned, the black markings are above the blue markings. 1000 is more than 998. Obviously children, I told you last time that even at YTMs below 12%, this black line will be curving upwards, right? It will be having a value higher than the blue line because it's a convex shape. Now children, moving on, now see, I'm again now in this particular example going to make two more columns. Please be attentive. Okay, two more columns I'm going to make. So children, one column will be percentage change in current market price, okay, as per the derivative function, that is as per the volatility. And second, I'll write percentage change in current market price actual. Okay, actual. So children, now these columns I'm making just so that I can explain to you the convexity formula that you're supposed to use in the exam. And for that, I'll take any one example here. Let me take the example of this 15%. Okay, I'll just mark it here. Okay, this, I am taking this example here. Please be attentive. Okay, now as per the derivative function, children, do you understand that if the YTM goes from 12 to 15, current market price should drop from 952 to 882.03. Do you agree? And that is nothing but a drop of 2.45% multiplied by 3%, right? Because from 12 to 15, if there is a 3% rise in the YTM, then considering the derivative function of 2.45% for every 1% change, this should change by 7.35%, which is what we must have taken to calculate the CMP. So therefore children, I'll write down here 7.35%. okay, 7.35% is what the change in current market price should be as per the derivative function, as per the volatility, that is the V, of 2.45% for every 1%, so 7.35% for 3%. But the actual delta percentage in current market price will be 952 minus 885.84 divided by 952 into 100. So let's do it. 952 minus 885.84, okay, 885.84 divided by 952 into 100, that should give us 6.95%. okay, I'll write down here 6.95%. So children, in reality the bond price has fallen only by 6.95%, but according to the volatility model, that is the first derivative, do you understand the derivative function is saying that no, the fall should be 7.35%. So children, these two are not same, and that is why there is that convexity, right? So in fact, just to make things more clear for you, I'll write this 6.95% in black ink. Everyone now understands. Okay, so moving on, as per the derivative, the drop should have been 7.35%. as per actual, it is 6.95. Now children, convexity will now help you bridge this gap. Everybody clear? Convexity will now help you bridge this gap. How? Let us see. So children, listen very carefully. Okay, I'll just write down. See, there are two formulas that you need to by heart from exams point of view. Please be very attentive. Okay, so I'll write down here bond convexity formulas. Okay, bond convexity formulas. The first formula that you need to remember is percentage change in current market price is equal to minus V into delta Y, the whole plus convexity into delta Y square. Okay, so this is the first formula, minus V into delta Y plus convexity into delta Y square. The second formula, children, is obviously of convexity. Okay, so convexity is equal to V plus V minus 2V0, the whole divided by 2V0 into delta Y square. Okay, so I'll explain everything about it. Don't worry, please be attentive. Okay, there are two formulas, and now let's try to understand what this is all about. Okay, so children, where I'll write down here, where minus V refers to volatility. Okay, it refers to volatility, that is the modified duration. Okay, then children, delta Y refers to change in YTM. Okay, delta Y refers to change in YTM. And then convexity, you know what it is all about. Okay, with numbers you'll get more clarity. What is V plus and V minus? I'll write down here only. Okay, see, V plus refers to, okay, current market price if YTM changes positively, and V minus refers to current market price if YTM changes negatively. Everybody clear? So children, and of course V0 refers to actual current market price. Okay, V0 refers to actual current market price. I'll write down here actual current market price, that is the base current market price. Okay, base current market price. Now all these terms with numbers will get clarity. So let's start how to do it. So first of all, children, first of all, what they're saying, percentage change in current market price. So children, I'll write down here percentage change in current market price is equal to, now children, please let's go back to our example, and right now I'm focusing on which two numbers here, children. Do you understand? I am talking of this change here from 12 to 15. Okay, so if YTM goes from 12% to 15%, what should be the change, the percentage change in the current market price? Now children, as per reality, can I say the answer is 6.95%, and as per the first derivative the answer was 7.35%. Let's now understand this. Please be attentive. Okay, so now children, according to the formula, what is the formula for percentage change in CMP? This they have given, right? This part. Now please be very attentive on this formula. What they are saying, that if there is a change in the yield, then the current market price will change by yield into volatility. Obviously that was the first derivative, right? So if there is a 3% change in YTM, do you understand that the bond price will change by 3 into the volatility of 2.45%? Everybody clear? 2.45 times. So 2.45 into 3, children, that was, if you remember, 7.35%. Yes, here you can see the 7.35% is nothing but this part here. Okay, this part here is that 7.35%. Everyone following till here? So children, I'm taking this example of YTM changing from 12% to 15%. Okay, YTM changes from 12% to 15%. That is a 3% change in YTM. Then according to the V, the volatility of 2.45% for every 1% change, do you realize total change should be minus 7.35%. Why minus? Because when the yield increases, price decreases. Everybody clear? So this part here, this particular bracket here, children, correct, this first bracket here is nothing but 7.35%. Do you agree with me? So I'll just write down here. okay, I'll write down here minus 2.45 into 0.03, correct? Minus 2.45 into 0.03. 0.03 is nothing but the 3% change in yield multiplied by minus 2.45, and children, you all know this is nothing but minus 7.35%, okay, minus 7.35%, or you can write it down as minus 0. Okay, minus 0.0735, correct? Minus 0.0735. Everybody agreeing with me till here? But they're saying no, this is not it. There is a slight adjustment that you need to do. If you do not do an adjustment to this particular percentage, then children, you will lie on the blue line. You will not be able to touch the black line. So that adjustment, children, is this part here. Everybody clear? This part will take you from the blue line to the black line. The convexity will be bridged here. So they are saying plus convexity into delta y square. So I'll just write down here, okay, plus convexity into delta y square. Everybody agreeing with me till here? Delta y is 3%, right? So now children, how do we solve this? For that there is a second formula, okay? The second formula is convexity, okay? Second formula is convexity. Now children, in that convexity, first of all I'll explain to you the terms that you know. This v plus and v minus you forget. 2v0 I'll explain. Children, 2 you know, 2 is nothing but 2. V0 is the actual current market price, that is the base current market price. So children, the base current market price is 952 rupees. Everybody clear? The base current market price is 952 rupees when the YTM is 12%. So I'll just write that down first, okay? So it is something plus something, okay? This V plus V minus, and then minus 2 into 952. Do you understand? 2 into 952, the whole divided by, children, it is 2v0 again. So I'll write down here 2 into 952 into, and now they are saying delta y square, okay? They are saying delta y square. So now in this bracket, of course, students, delta y square means, you know, it is 0.03. That is the delta of YTM, 3% we're changing, right? Great. Now the only thing left now to understand is what is V plus and V minus. V0 you know, right? So let me now explain that to you, children. See, I'll just draw one graph here, okay? See, this is center. I'll place it as V0. This I will place it as V minus and this as V plus. Which means, children, if 952 is the center, okay, when the YTM was 12%, what is the current market price when the YTM changes by 3%, both upwards as well as downwards? Everybody clear? 12 plus 3% and 12 minus 3%, both will have to take. So children, do you realize when the YTM is 15%, okay, when the YTM is 15%, we know that the current market price, the actual current market price, children, is 885.84, correct? 885.84. Everyone following till here? So I'll just write down here 885.84. Everyone following? Next, children, if the YTM drops to 9%, please pay attention, if the YTM drops to 9%, what will be the current market price? For that, children, what I will do is I'll first of all remove all these markings now to get little bit clarity. Okay, I'll remove all these markings. All right, so I'll just write down now here 9%, okay? In blue ink, I'll first of all write down 9%. Okay, 9%. Ready? And now, children, I do not want the current market price as per the derivative function. I want the actual current market price at 9%. So children, if I do it at 9%, this will be 100 divided by 1.09 equal to m plus equal to m plus equal to m plus 1000 divided by 1.09, 1, 2, 3 m plus MRC. And this, children, will come to, in the black ink I'll write down, actual figure is 1025.3. okay, 1025.3. so where will I write it? Here I'll write it, okay, 1025.3. everyone clear? So children, V0 was the base YTM CMP, correct? That is 12% discounting current market price. That is the actual current market price, and we are looking at a 3% change in YTM. So both upside and downside will take, plus 3% minus 3%. So at 15%, whatever price you get will be the V plus. At 9%, whatever price you get will be the V minus. Let us post it here, children. So V plus is 885.84. Okay, V plus is 885.84, and children, V minus is 1025.3. Okay, 885.84 plus 1025.3. So children, let's now take the calcs and solve this. So I'll just take it downstairs here. Okay, I'll take it downstairs. So the numerator, we have 2 into 952 m plus 885.84 plus 1025.3 m plus MRC. This comes to 7.14 in the numerator, and in the denominator, children, we have got 0.03 into equal to into 952 into 2. This is 1.7136. Okay, 1.7136. I'll just write down here 1.7136. So this comes to 7.14 divided by 1.7136, and that comes to, children, 4.17. Okay, this is 4.17. Everyone clear till here? 4.17. So children, what is this 4.17? This is your convexity. Okay, this is your convexity. So children, convexity we now got as 4.17, and therefore this, children, we can place it here. Okay, we can place it here as 4.17 in the first formula, and we can find out the total change in the current market price. Can we start? So children, here the second half of this formula will be 0.03 into equal to into 4.17, and that will be, okay, 0.003753. Okay, 0.003753. So let's now take the calc and solve this. Minus 0.0735 plus 0.003753. Okay, children, so this will come to 0, okay, or basically minus 0.069. that is nothing but 6.9%. 6.9%, children, negative. Negative in a sense, when the yield goes up by 3%, the bond price should fall by 6.9%. Let us see, in reality it has fallen by how much? Yes, children, it has fallen by 6.9% only. Everybody clear? So children, what we just managed to do is this 7.35 that we had got earlier as 2.45 into 3, in that we were able to make this small adjustment here, which I have shown in the red. That is the convexity adjustment. Everybody clear till here? And once you do that adjustment, children, then you will be able to bring this 7.35 to 6.9. Everyone follow until here? Actually, it is 6.975. So children, if you want, I can just write down here 6.97. Okay, 6.97. All right, and that, children, is a small rounding of difference between 6.97 and 6.95. Everyone clear? So like that, children, you can solve for convexity. So children, tell me, what will be the steps for calculating convexity? Therefore, children, the first step, okay, I'll write down here, first step is to calculate the V0. Everybody clear? The first step is to calculate the V0. The second step, children, will be to calculate the V plus and V minus. Everybody clear? V plus and V minus. Once you have that, delta Y, children, will be given in the question only. Okay, delta Y will be given in the question. And once you have all these numbers, children, then simply calculate the convexity formula. Once you have the convexity formula, you can easily put it in this percentage change in current market price formula and get the total. Everyone follow until here? So with that, students, we end this entire explanation of bond convexity. Now, two things I want to tell you, and after that we'll end this video. Children, as far as institute is concerned, okay, as far as institute is concerned, please be very, very attentive. If they ask you in the exam convexity of bond or just calculate convexity of bond, they are expecting you to calculate, okay, I'll just write down here, I'll put a marking here, they're expecting you to calculate this particular circle. Everybody clear? If they ask you convexity, they are asking you basically this circle. Don't stop here. Everybody clear? Don't stop here. So children, what ICAI does is, this convexity, it names it as capital C, and therefore here it writes down, okay, capital C into delta Y square is the convexity of the bond. doesn't matter. Okay, for me children, this is the convexity and this particular circle is the convexity impact. Okay, convexity is this formula and the upper one here is the convexity impact, where you simply take the convexity and multiply by delta y square is the convexity impact. But children, just informing that if the question asks you convexity of bond, then please do this particular thing, that is C into delta y square, where C is the convexity and this particular formula is C and this particular is the convexity of the bond, which I can also call it as convexity impact. Everybody clear? Convexity impact. So welcome to this video where I will be discussing with you November 2020 CF final SFM paper, new syllabus, in that question number 3A. Okay, question number 3A. Children, this particular question we'll be picking and discussing now. Alright, so children, I request everyone to please first of all pause the video and read the question carefully. Start. Okay friends, I hope you all read the question. Let us now try to understand this. Point number A. The following data are available for a bond. Face value 10,000 to be redeemed at par on maturity, which means children, the redemption value is also 10,000. Coupon rate 8.5%, years to maturity 5, yield to maturity 10%. This is the YTM given to you. You are required to calculate point number 1, current market price of the bond. Children, current market price of the bond, very simple. Can I say I have to just discount the future cash inflows at the rate YTM to find the CMP? So I'll just write down here. Okay, point number A. Okay, question number 3A. Okay, question number 3A of the paper there. Okay, and in that children, the first point they are asking you is the current market price. Okay, so CMP children is nothing but present value of all future cash inflows from the bond. Okay, of course discounted at the rate YTM. Can we start? So children, what is the face value of the bond? 10,000. Coupon rate is 8.5%. so 10,000 into 8.5%, 850 will become your coupon or the interest every year for the next 5 years. So I'll write down here 850 into PVAF of, what is the YTM given children? 10%. So I'll multiply by 10%. How many years? 5 years, correct? Years to maturity is 5 years. So 5 years plus the redemption is at par. So 10,000 into discounting factor of 10% fifth year. Can we start children? 850 into children PVAF of 10% 5 years is 3.790 plus 10,000 into discounting factor of 10% fifth year is 0.621. We are taking 3 decimals here. Okay, so children, 850 into 3.79 m plus 10,000 into 0.621 m plus MRC, this will come to 9,431.5. okay, 9,431.5 is the current market price. Let's see what ICAI is getting. Yes children, they are getting the same answer, 9,431.5, point number 1. Everyone clear till here? So with that children, we complete this point number 1. Let us now go to point number 2. They're asking you the duration, Macaulay's duration. Children, duration, we will need to make a table, right? So I'll just write down here point number 2, calculation of duration. Okay, calculation of duration. What columns will we make children? Year, cash inflow, discounting factor at the rate 10%, present value, and then year into present value, the normal table. 1, 2, 3, 4, 5. Okay, then 850, 850, 850, 850, and then 10,000, 850. As far as discounting factors are concerned, 0.909, 0.826, 0.751, 0.683, 0.621. Children, let's calculate this. Of course will be the current market price. So 850 into 0.909 m plus, this is 772.65. then 850 into 0.826 m plus, this is 702.1. then 850 into 0.751 m plus, this is 638.35. then 850 multiplied by 0.683 m plus, this is 580.55, and then 10850 into 0.621 m plus, this is 6737.85, and then MRC of course is 9431.5. Now children, let's do the year into PV calculations. 1 into 772.65 m plus 2 into 702.1 m plus 3 into 638.35 m plus 4 into 580.55 m plus 5 into 6737.85 m plus MRC. This comes to 40,103.35, and therefore children, the duration, okay, the duration will be 40,103.35 divided by 9431.5. Okay, if I divide by 9431.5, I get the duration as 4.25 years. I'll write down here 4.25 years. Let's check what institute is getting. Okay, yes, 4.252. We also got 4.252. Big deal. Write down here 252. Same answer. Okay, so with that children, we complete Macaulay's duration. Let's go to volatility. Children, as far as volatility is concerned, I'll write down here point number 3. Volatility, it is also called as modified duration. Okay, modified duration. Macaulay's duration is the original duration. Modified duration, if they ask you, it is volatility. The formula is duration divided by 1 plus yield. Correct? Your duration, children, is 4.252 years divided by, children, the YTM was 10%, so 1.10. So children, 4.252 divided by 1.1 will give you 3.865. Okay, 3.865% for every 1% change in YTM, which means for every 1% change in YTM, the bond price will change by 3.865%. So yes, they also have got 3.865, point number 3. So with that, we complete point number 3. Point number 4 now children, they're asking you convexity of the bond. Okay, convexity of the bond, children, I hope you remember the formulas. I will just show it to you here again. Okay, see, you remember this formula of convexity? Yes, convexity is equal to V plus V minus minus 2V0, the whole upon 2V0 into delta Y square. So students, here please pay attention. Okay, see what they are saying, convexity of the bond, and down they are saying the YTM decreases or basically changes by 200 basis points. Children, 200 basis points means a 2% change in YTM. So for a 2% change in YTM, what will be the convexity is what we have to calculate and give. Can we start? So children, I'll just keep this formula now in front of you. Okay, and what I will do is I'll just place this sheet here and I'll write down here point number 4. Okay, point number 4. Convexity, okay, is equal to, convexity is equal to, now children, do you understand that it is equal to this formula? Okay, this particular formula. But students, if you want the exact adjustment of convexity, do you understand this is the final formula? Everybody clear? So this is of course the convexity formula, but when you just apply it on the main formula here, this will give you that gap, right, between the blue and the black lines. I hope you remember that, right? So children, I'll write down here convexity is equal to, okay, V plus V minus minus 2V0, the whole divided by 2V0 into delta Y square. Okay, and convexity impact, okay, convexity impact will be, children, do you understand? It will be convexity formula into delta Y square. Okay, so I'll write down here convexity into delta Y square. Okay, convexity into delta Y square. Can we start? So for that children, can I say we will require the V plus, the V0 and the V minus. Everyone clear? Now children, we all know V0 is at the rate 10%, right? That is the base YTM. V plus, children, 2% is the change. So do you realize at the rate 12% and this will be at the rate 8%, 2% less, right? So V plus is 10% plus 2%, that is the current market price at 12% YTM, and V minus will be the value or the current market price at 10% minus 2% YTM, that is 8%. So children, as far as V0 is concerned, we already have the V0, right? We already have the V0 as 9431.5. So I'll just write down here 9431.5. As far as V plus and V minus is concerned, we'll have to calculate them. So children, I'll just write down V plus, that is current market price at the rate 12% will be, children, of course it will be 850 into PVAF of 12% 5 years, correct, and plus 10,000 into discounting factor of 12% fifth year. Everyone clear with this? Which is equal to 850 into, now if you take 3 decimals in 12%, the PVF will be 3.604 plus 10,000 multiplied by 0.567. 12% fifth year is 0.567. So children, 850 multiplied by 3.604. Okay, 850 into 3.604 M plus 10,000 into 0.567 M plus MRC, and this will come to 8733.4. So children will write down here 8733.4. Now children, let's do for V minus. So I'll write down V minus, that is, okay, that is current market price at the rate 8%. Children, this will be again 850 into PVAF of 8% 5 years plus 10,000 into discounting factor of 8% fifth year. So children, now let's do this. So I'll write down here 850 into PVAF 8% 5 years, 3 decimals will be 3.993 plus 10,000 into discounting factor 8% fifth year is 0.681. So I'll write down here 0.681. So children, 850 into 3.993 M plus 10,000 into 0.681 M plus MRC, this will come to 10,204.05. okay, 10,204.05, 10,204.05. Everyone following till here? So children, now we will get that convexity formula here. Children, V plus plus V minus means, children, can I say this will be 8733.4 plus 10,204.05 minus 2V0. V0 is 9431.5. So I'll write down 2 into 9431.5, the whole divided by 2V0 again, 2 into 9431.5. Correct, children? Here the delta of y is 2%. So I'll write down 0.02 square. Can we start? So children, let's now take the calces. In the numerator we have got 2 into 9431.5 M minus 8733.4 plus 10,204.05 M plus MRC. This is 74.45 in the numerator, and then downstairs, children, we have got 0.02 into equal to into 9431.5 into 2. This is 7.5452. So children, 74.45 divided by 7.5452 will give you 9.87, or for 3 decimals we can write it as 9.867. okay, 9.867. Everyone clear with this? Okay, so now children, to find out the final convexity impact, okay, convexity impact, all right, or just we can write it as convexity. Students, do you realize it will be the C multiplied by delta y square? Okay, C multiplied by delta y square. And children, to give it a percentage form, we can of course multiply by 100. So this will be 9.867 multiplied by 0.02 square into 100. So children, on the calci, 0.02 into equal to into 9.867 into 100 should give you 0.39468 or 0.395% as the convexity impact. That is the difference between the blue line and the red line. Let's see what ICAI has got, children. ICAI has also done calculations of convexity. Yes, they also got 9.867, and 0.395% as the convexity impact. Everyone clear with this? So with that, children, we complete this question number 3, point number 4, and now last point is left, children, point number 5. They are saying what is the expected market price if there is a decrease in the YTM by 200 basis points, which means if YTM drops to how much percent? Drops from 10% to 8%. Okay, it goes down by 2%. What will be the current market price? Using the Macaulay's duration based estimate, which means using the volatility, which means using the first derivative function. Everybody clear? So using volatility, using Macaulay's duration, what is the estimate? Children, do you understand actually this particular point number A is nothing but the blue line? Everybody clear? And children, now they are asking you by the intrinsic value, means the actual value they are asking you, that is of course that black line. Everyone clear with this? So students, as far as the black line is concerned, we already have the answer, correct? We already have the answer here. We had calculated that at 8%, children, the actual value is 10,204.05. So I'll just write down here. Okay, I'll write down here. By intrinsic value model, the answer is 10,204.05. And as far as the duration model is concerned, children, as far as duration model is concerned, I'll just tell you the answer in a bit. See, children, what is the volatility that we have got in this particular question? In this question, we have got volatility as 3.865, which means for every 1% change in YTM, correct, the bond should change by 3.865 times, or 3.865%. So children, if the YTM is going to change by 2%, the bond will change by 3.865 into 2%, right? So here, children, what was the original V0? What is the original price of this particular bond? It is 9431.5, right? At 10% it is 9431.5. So what I will do, I'll write down here 9431.5. Now children, if the YTM at 10%, 9431.5 is the current market price. If the YTM drops by 2%, the price of the bond will increase, correct? It will increase by, children, according to the duration formula or according to the volatility, if there is a linear drop, children, what should be the drop? Children, do you understand the volatility that we have got is 3.865 for 1%. So for 2% it will be 3.865, okay, into 2. Everybody clear? Into 2% basically. So children, now 3.865 into 2, that means there should be a 7.73% jump in the bond price. So 9431.5 plus 7.73%, the answer comes to 10,000, okay, 160, 10,160.55, okay, 10,160.55. So if the bond has to lie on that straight line, the blue line, the bond price according to the first derivative function is 10,160, but in reality the convexity is there, which is why, children, do you realize it is actually 10,204. The volatility also is subject to change as the YTM changes, which is why there is that curve. So students, these are the two answers, 10,160.55 and 10,204.05. Let us check the institute solution here. Okay, now according to the institute solution, yes, they have got the same answer, 10,160.55, and children, 10,204.05 is what the answer is. And children, this, therefore they have given the expected market price is 10,204. Everyone clear with this? So with that, children, this price increased by is given to you, but that is not asked in the question, so we'll ignore it. Okay, so with that, children, we complete this question number 3 of ICEI November 20 SFM paper. I hope you understood how to solve for bond convexity. Yes, if they ask you convexity of the bond, I'll again repeat, if they ask you convexity of the bond, you have to calculate that convexity, but also the convexity impact, right? In which you do the convexity multiplied by the delta y square. Okay. So thank you very much, students. I hope you understood the entire new module of bond convexity. Thank you.